All right, so I just want to do a short lesson overview and show you guys what you're going to be working on as far as this goes. So this part should be review, but we're looking at the model that's for our POGL, and we're looking at the Lewis structures that we draw for ionic bonds. So here's sodium chloride, right? It forms an ionic bond. This is what the Lewis dot structure looks like. So I'm going to walk you through both that and the chemical formula as an example. So go to my presentation screen. So we have sodium and we have chlorine. If I look on the periodic table, first thing I want to know is what kind of bond is it going to form? Okay. And I know it's ionic because I just have to look at the fact that sodium, he's here, a metal, right? And chlorine is a nonmetal, right? So here's my dividing line between metals and nonmetals. So I know it's going to be ionic. I know sodium has one valence electron because it's in this first column. And I know that chlorine has 7 valence electrons. We learned from the last assignment that they want to be stable. That makes them happy. They want noble gas configuration. So sodium has 1 valence electron, chlorine has 7. So in order for sodium to be happy, it is a metal. And so it is going to lose its electron by definition of forming an ion. It's a cation, remember. So it will lose an electron. Chlorine will gain an electron. So let's go through that really quickly. Grab my space pen. So here is sodium. It's got 1 valence electron. Chlorine has 7 valence electrons. Okay. Okay. So now if chlorine wants to be happy, it's going to take its valence electron and transfer it to chlorine, which will give chlorine a total of 8 valence electrons. By losing its electron, sodium also has 8, right? Because it just started filling, remember the orbitals, right? The energy levels was all covered in quarter 3 when we talked about chemical bonding. So this is all review. So how do we do a Lewis dot structure for an ion? Okay. Remember we talked about the brackets. Okay. Let's get rid of that. So I'm just going to move this closer. Oops. All right. That should be plenty close. Okay. And then I need my brackets. So it's actually going to be easier if I erase all my little dots. Okay. Now I want to draw, I'm just going to type the bracket, little space. Right? So now I need, grab my space pen, because it transferred the electron for a total of 8, the one lone electron. So now it lost electron, it's a cation, so it has a positive 1 charge, gained an electron. So that is the Lewis structure, and that's the process to get to the Lewis structure. Now let's say I want to do the chemical formula. So if I just want the chemical formula, then I don't need all this, right? Get rid of all these dots and drawings. I don't need the bracket. I just literally type NaCl. Okay. So some of the questions will ask you for chemical formula, some will ask you for Lewis dot structure. That's how to do it. So real quick, I just wanted to review this other example in POGIL, right? So we have CaCl2. So why do we need 2 chlorines in the chemical formula and only 1 calcium? Okay, so let's look at our periodic table. Calcium's here in that second column. So when it forms an ion, right, it's going to give up how many valence electrons? 2. Chlorine still has 7 valence electrons. So if we go over here, I've already filled in the dot structure, right? The cation is going to lose the electrons. So what happens? Goes right over there. This one goes over there, right? That's why you need 2. It's all about balancing. It's sort of like that octet rule. So I'm going to let you guys figure out the formula and figure out the Lewis dot structure. Remember the brackets, right? And you also want to include the charge, just like in the POGIL. So I thought that would be a good one to review because you're going to need to know that.